And then reciprocal of -1 is still -1, so -1/4 using -1 plus c. Okay, well, it's not done yet because you have to convert back to x, because this is just still u. Okay, the original problem was in terms of x. I keep erasing it a couple of times already, so let me rewrite the original question up here so you guys see it. Integral of 1 over x squared square root of x squared plus 4 dx, right? Now you have this. And what is your u? U is sine theta. So this is -1/4 sine inverse of theta plus c. Sine inverse is cosecant, right? So this is -1/4 1 over sine theta, then plus c, right? Sine inverse of theta is 1 over sine theta. But this is still not the answer yet, because everything got to be in terms of f. Now you have something in terms of theta. Here comes a very, very important step that you guys should have learned it already in trigonometry class. But if not, I'll bring it back to you right here. Recall the very first step, we let x equal to, what's that? 2 tangent, right? 2 tangent theta, I think. Yes, this is the very first step that we did. Okay, so how do we convert from theta back to x? Here is a technique that you guys are going to use. Draw a right triangle for me. It's too big of a right triangle, so I'll make it smaller. Okay, the angle theta is somewhere right there. This is the right triangle. All right, so x equals to 2 tangent theta means what? Tangent theta is x over 2. And I'm going to use some trigonometry in here. Tangent is opposite over adjacent thing. So this is the angle theta right here. So this is going to be opposite is x. Adjacent is 2. And tangent theta is going to make sense. X over 2. Okay? So using the Pythagorean theorem, this is 2, this is x. The hypotenuse side going to be x squared plus 2 squared. And that takes square root. So x squared plus 4. This is the side. Okay. So I got everything about the right triangle with the angle theta in there. So I can calculate sine of theta. So sine of theta, sine is opposite over hypotenuse. That's going to be x over square root of x squared plus 4. So 1 over sine theta, 1 over sine theta, which is cosecant theta. We're going to make the reciprocal of this. X squared plus 4 over x. Now that you have the answer, that's going to be -1 over 4. Then 1 over sine theta is going to be square root of x squared plus 4 and over x. And then don't forget the plus c at the end. Okay. You see why I say that this type of trick stuff is going to be complicated, going to be hard, because you guys got to follow a lot of steps and a lot of techniques involved in the problem to get to the answer. But it works, okay? It's just powerful, and it gives you the right answer. That's just the thing. Now, let me show you another one. And I claim that actually with this second problem, you guys can do the regular use up. You can have the answer. But let me just pretend that I don't know it. I'll do tricks up for you. See how long it takes. Then I'll come back and do the same problem again using the use up and see how fast it is. Integral of, let's see what we have right here. X over square root of 4 plus x squared dx. Okay, so I see what radical of 4 plus x squared. I can change the number, but let's do the same number so that you guys can get ahead of it. I see that I got a type of square root of 4 plus x squared, so I can think of tricks up in here, tricks up, and I'm pretty sure it's going to work. The question is a matter of time, how long it's going to take to solve the problem. So let's do it, tricks up. I'll let x equal to 2 times tangent theta. Okay. If I change this to 9, And you know what? You're going to let x equal to 3 tangent theta, right? Because 3 squared is equal to 9. Let's stick with this. Right? So, if x equal to 2 tangent theta, then dx is 2 secant squared theta d theta. The derivative of tangent is secant. Okay? So, our problem becomes the integral x is 2 tangent theta. The bottom is square root of 4 plus x squared, which is 4 tangent squared theta, and then dx is 2 secant squared theta d theta. So I convert everything from x to theta. X is 2 tangent theta. On the bottom denominator, square root of 4 plus x squared is now 4 plus 4 tangent squared theta, because x squared is 4 tangent squared theta. And then dx is 2 secant squared theta d theta. And let's try to simplify. Integral 2 times 2 is 4. I can bring the 4 outside first of all. I got tangent theta, I got secant squared theta, and then d theta on top. On the bottom, I got square root. Right? I can factor out the 4. I got 1 plus tangent squared theta. And you know that 1 plus tangent squared is secant squared theta. And then take square root, I got 2 secant theta on the bottom. So this is going to be 4 integral tangent theta secant squared theta d theta over 2 secant theta on the bottom. Okay? And of course, we can simplify more. Cancel out the 2, take out the 2 on the top and bottom. I got 2 left. Cancel the secant. I got integral of tangent theta secant theta d theta. Okay. Now, you can see the answer right here because the derivative of secant is going to give me tangent and secant. So this is no more than 2 times secant theta plus c. Right? See? Let u equal to du equal to tangent theta secant theta d theta. Or just see the answer directly because the derivative of secant is tangent secant. So integral of tangent secant is just secant theta. Okay? But you have to convert all the way back to x, right? I got 2 secant theta right here. How do you convert theta all the way back to x? Okay. Draw the right triangle again. This is the second time that I show you this trick, the technique. I said x, tangent of theta. Is equal to x over 2, right? Tangent of theta is x over 2. And this is my right triangle, this is the angle theta. I know the tangent is opposite over adjacent, so opposite over adjacent is going to mixture of x over 2. X is on the opposite and 2 is on the adjacent. So the hypotenuse is going to be square root of x squared plus 4. I'm using the Pythagorean theorem. I have this. So secant theta is the reciprocal cosine, so hypotenuse over adjacent. Secant of theta is equal to 1 over cosine of theta, which is, cosine is what? Adjacent over hypotenuse. So 1 over cosine hypotenuse over adjacent. So square root of x squared plus 4 over 2. So you will have the answer for the problem. This is 2 times square root of x squared plus 4 over 2 plus c. And of course you can cancel out the 2. You have the answer, which is square root of x squared plus 4 over 2. Square root x squared plus 4 and plus c. So anyway, with tricks up, you have to do that much work. And then you have the answer as square root of x squared plus 4 plus c. That's the answer. Now, let me show you another way to tackle this problem. This specific problem using just a regular use up that you guys learned in Count 1 already. I see that I got x dx. The bottom I got square root of 4 plus x squared. So I can let u equal to 4 plus x squared. Then du is 2x dx. Okay? So x dx right here is du over 2. X dx is 1/2 du. Okay? So this problem right here. integral of x dx over square root of 4 plus x squared will become x dx is 1/2 du, and then what? U plus x squared, this is square root of u. Right? And this is 1/2 integral of u to the negative 1/2. This is my negative 1/2 du. Then you can do power rule. This is 1/2 integral of u to the negative 1/2. This is negative 1/2. Let me write clearer. Negative 1/2 at once is going to be u to the 1/2, and then times 2, and then plus c. So 2 with the half cancel out, u to the 1/2 is square root of 4 plus x squared, and then plus c. All right, so it's going to be much shorter to get to the answer using u sub instead of trig sub. Okay, let me show you another way of tackling this problem using u sub again. It's a little bit different than the first sub. But it worked just fine. Okay, instead of let u equal to 4 plus x squared, I'm going to do this. Let u equal to the whole thing on the denominator. So square root of 4 plus x squared. You won't see it in the book. Okay. Then what? U squared is equal to 4 plus x squared. I'm just squaring up both sides. Okay? And then I differentiate both sides. I got what? 2u du is equal to 2x dx, because the derivative of 4 is 0 already. U squared derivative power rule, right? 2u du. X squared derivative 2x dx. You cancel out the 2. You got u du equal to x dx. So this problem, integral of x dx over square root of 4 plus x squared will be equal to integral x dx is u du over square root of 4 plus x squared, just another u. So that u cancel out. This is integral of du, which is u plus c, which is square root of 4 plus x squared, and then plus c. It's even faster. Huh? So the key is how to do u sub. So I tried to emphasize that many problems actually you guys can do u sub, and you may not have the only choice. You may have more than one choice of u sub to get to the answer. Okay, so I was studying math. Just try and learn more and more. You find a new way, just try it, and don't hesitate to make mistakes. If you didn't find the right answer, then come back and try another way. That's how we learn. Okay. That will be the end of section 7.3 today, and let me try to add a little bit more, just in case for those who want to learn some advanced techniques or another way to learn, because I know that many of you guys may not learn this in Calc 1, but we should have it. It's something called the hyperbolic trick. Trigonometry. Okay, for those who learn already, it's going to be familiar. If not, then at least you know it. If you don't know it, that's okay. Just use the regular trick, the sine, cosine. So hyperbolic trick, you got this. Hyperbolic sine, you got hyperbolic cosine, hyperbolic tangent, hyperbolic cotangents, hyperbolic cosecant, hyperbolic secant. Okay, just with an h after the sine, cosine, the regular trick. And you have some trig formulas, and this is this. I think cosine, hyperbolic cosine square minus sine square equal to 1. You have then divide both sides by cosine. You have 1 minus hyperbolic tangents square of x equal to hyperbolic cosine, so secant square of x. Okay, and then derivative of sine is cosine. Derivative of cosine, just sine. All right, no more negative. And I claim that if you know some trick and answer for hyperbolic trick, you can apply everything that we learned in 7.2 and 7.3 on hyperbolic trick. Okay. just look it up for more trick or anything. I'll just write down some typical ones on top of my head. And I claim that if you know how to apply the trick, the problem's going to be shorter, going to be less step to solve with hyperbolic trigonometry on many problems. Okay, if not, that's okay, because I see that the book did not mention this much, just very little. So, but this is pretty useful. So hopefully that helps for those who want or love to learn more about this stuff. Okay. All right, let me stop the clip right here. Thank you for watching, everyone. As usual, any question, please ask. Okay. There's both ways, many ways for me to help you, or many ways for you guys to ask me, like email, like many of you guys do, or just set up a conference, a meeting via webcam, and I'll more than help you to help you. Any question that you have for your study. Thank you one more time. Have a great week, everyone.